National Electrical Code Section 404.2 states that shared neutral shall not be used in circuits supplying dimming control ballasts or transformers. This code requirement is in place to address the potential fire hazard caused by voltage feedback and harmonics on shared neutral wires. When dimming circuits feed voltage back onto the neutral wire, it can create voltage imbalances and overloads, which can lead to overheating and fire. Additionally, National Electrical Code Section 404.2 states that neutral conductors shall not be used for carrying load current by intentionally connecting them to the grounded circuit conductor or to the equipment grounding conductor. This requirement reinforces the prohibition on using shared neutrals in dimming lighting control circuits. Therefore, it is not permissible to use shared neutrals in residential lighting control circuits that include dimming lighting control circuits. To elaborate on the implications of these code sections, let's delve into the specific dangers associated with shared neutrals in dimming circuits. Firstly, understanding the function of a neutral conductor is crucial. In a standard alternating current or AC circuit, the neutral wire provides a return path for the current, allowing the electrical circuit to be complete and for power to flow to the load, such as a light fixture. The neutral is typically connected to ground at the service panel and is intended to carry only the imbalanced current between the hot wires in a multi-wire branch circuit. Secondly, dimming circuits introduce a complex element to this system. Dimmers work by rapidly switching the voltage on and off, effectively reducing the average power delivered to the light. This switching action introduces harmonics into the electrical system. Harmonics are currents and voltages at frequencies that are multiples of the fundamental frequency, which is typically 60 Hz in the United States. Thirdly, these harmonics can cause significant problems in shared neutral systems. In a multi-wire branch circuit with a shared neutral, multiple hot wires share a single neutral conductor. Under normal circumstances, the currents in the hot wires partially cancel each other out in the neutral wire, reducing the current the neutral carries. However, when dimmers are used, the harmonic currents generated by the dimmers do not necessarily cancel each other out in the neutral wire. In fact, they can add together, resulting in a neutral current that exceeds the capacity of the neutral conductor. This overload can cause the neutral wire to overheat, potentially leading to a fire. The prohibition in Section 404.2 directly addresses this issue by preventing the use of shared neutrals in circuits with dimming control ballasts or transformers. These devices are particularly prone to generating harmonics. Furthermore, the statement in Section 404.2 reinforces this prohibition by preventing neutral conductors from carrying load current by intentionally connecting them to the grounded circuit conductor or to the equipment grounding conductor. This means that the neutral should not be used as a return path for any current other than the imbalanced current from the hot wires. This further restricts the use of shared neutrals in dimming circuits, as the harmonic currents can effectively cause the neutral to carry more current than it is designed for. In practical terms, this means that each dimming circuit should have its own dedicated neutral conductor that runs back to the service panel. This ensures that the neutral wire is not overloaded with harmonic currents and reduces the risk of overheating and fire. When installing or modifying lighting circuits with dimmers, it is essential to follow these National Electrical Code requirements closely. Ignoring these requirements can create a dangerous situation that puts your home and family at risk. It is also important to use appropriately sized conductors for the lighting circuits. The size of the conductors should be based on the load they will be carrying, including any harmonic currents. Consult with a qualified electrician to determine the appropriate conductor size for your specific application. Furthermore, it is advisable to use high-quality dimmers that are designed to minimize harmonic distortion. These dimmers can help reduce the amount of harmonic current that is generated, which can further reduce the risk of overloading the neutral conductor. In addition to the National Electrical Code requirements, it is important to follow the manufacturer's instructions for installing and using dimmers. The manufacturer's instructions may provide additional information on how to properly wire the dimmers and how to avoid creating a fire hazard. Finally, it is important to have your electrical system inspected by a qualified electrician on a regular basis. This will help identify any potential problems before they become a safety hazard. The electrician can check the wiring, the conductor sizes, and the condition of the dimmers to ensure that everything is in good working order and that the system meets all applicable National Electrical Code requirements. To summarize, the use of shared neutrals in dimming light and control circuits is prohibited by the National Electrical Code to prevent fire hazards due to voltage feedback and harmonics. Adhering to sections 404.2 D2 and 404.2 is crucial for ensuring electrical safety in residential settings. Remember to use dedicated neutrals for dimming circuits, properly size conductors, use high-quality dimmers, follow manufacturer's instructions, and have your electrical system inspected regularly. All of these steps will help protect your home and family from the dangers of electrical fires. Remember, safety is paramount when working with electricity. If you are not comfortable working with electrical wiring, it is always best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to safely install and maintain your electrical system. They can also ensure that your system meets all applicable National Electrical Code requirements. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety practices. The National Electrical Code is adopted by most states and local jurisdictions in the United States. When installing or modifying electrical wiring, it is important to follow the National Electrical Code requirements. This will help ensure that your electrical system is safe and reliable. In addition to the National Electrical Code, there may be other local codes and regulations that apply to electrical wiring in your area. It is important to check with your local building department to determine the applicable codes and regulations. Following these codes and regulations will help ensure that your electrical system is safe and compliant. Electrical safety is a serious matter. Electricity can be dangerous if it is not handled properly. Always take precautions when working with electricity. Wear appropriate safety gear, such as rubber gloves and safety glasses. Never work on electrical wiring while it is energized. Always turn off the power at the breaker box before working on any electrical wiring. If you are not sure how to do something safely, ask a qualified electrician for help. By following these safety precautions, you can help protect yourself and others from the dangers of electricity. When dealing with electrical systems, especially those involving dimming circuits, it is important to have a thorough understanding of the underlying principles and potential hazards. Let's explore some of the key aspects in more detail. Firstly, the behavior of dimming circuits can be quite complex due to the nature of the electronic components involved. Modern dimmers often use solid-state devices such as silicon-controlled rectifiers, or SCRs, or transistors to rapidly switch the voltage applied to the light fixture. This switching action creates a chopped waveform, which is different from the smooth sine wave of the standard alternating current power supply. This chopped waveform is what introduces harmonics into the electrical system. Secondly, harmonics are not just theoretical concepts, they can have real-world consequences. They can cause equipment to overheat, damage sensitive electronic devices, and interfere with communication systems. In the context of lighting circuits, harmonics can overload the neutral conductor, as discussed earlier, but they can also cause other problems. For example, they can cause transformers to overheat and fail, and they can interfere with the operation of other electrical equipment on the same circuit. Thirdly, the National Electrical Code addresses the issue of harmonics in several different sections. In addition to sections 404.2 D2 and 404.2a, there are other sections that deal with harmonics in general. For example, section 220.3c requires that the neutral conductor in a multi-wire branch circuit be sized to carry the maximum unbalanced load, including any harmonic currents. This means that the neutral conductor may need to be larger than the hot conductors in some cases. Furthermore, section 310.15b3 provides guidelines for derating conductors that carry harmonic currents. Derating means reducing the allowable ampacity of the conductor to account for the heating effect of the harmonic currents. These derating factors can be significant, especially in circuits with high levels of harmonic distortion. Fourthly, when designing or modifying lighting circuits with dimmers, it is important to consider the potential impact of harmonics on the entire electrical system. This may involve performing a harmonic analysis to determine the levels of harmonic distortion that are present. A harmonic analysis can be performed using specialized test equipment that measures the voltage and current waveforms in the circuit. The results of the harmonic analysis can be used to determine the appropriate conductor sizes, derating factors, and other measures to mitigate the effects of harmonics. Fifthly, in some cases, it may be necessary to install harmonic filters to reduce the levels of harmonic distortion. Harmonic filters are devices that are designed to block or reduce the flow of harmonic currents. They are typically installed at the service entrance or at individual loads that generate high levels of harmonic distortion. Harmonic filters can be effective in reducing the overall levels of harmonic distortion in the electrical system. Sixthly, it is also important to consider the type of dimmers that are being used. Some dimmers are designed to minimize harmonic distortion, while others generate high levels of harmonics. Dimmers that use advanced control algorithms and filtering techniques can significantly reduce the amount of harmonic current that is generated. These dimmers are typically more expensive than standard dimmers, but they can be worth the investment in terms of reduced harmonic distortion and improved electrical system performance. Seventhly, the use of LED lighting has also introduced new challenges in terms of harmonics. Some LED bulbs and fixtures can generate significant levels of harmonic distortion, especially when they are used with dimmers. It is important to choose LED lighting products that are designed to minimize harmonic distortion. Look for products that are labeled as being harmonic-free or low harmonic distortion. Eighthly, when installing LED lighting with dimmers, it is important to ensure that the dimmer is compatible with the LED bulbs or fixtures. Not all dimmers are compatible with all LED lighting products. Using an incompatible dimmer can cause the LED bulbs to flicker, buzz, or fail prematurely. Check the manufacturer's compatibility list to ensure that the dimmer and the LED lighting products are compatible. Ninthly, in addition to the technical considerations, it is also important to consider the safety aspects of working with electrical systems. Always follow safe work practices when installing or modifying electrical wiring. Wear appropriate safety gear, such as rubber gloves and safety glasses. Never work on electrical wiring while it is energized. Always turn off the power at the breaker box before working on any electrical wiring. Tenthly, if you are not comfortable working with electrical wiring, it is always best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to safely install and maintain your electrical system. They can also ensure that your system meets all applicable national electrical code requirements. Electrical systems, particularly those with dimming circuits, require careful attention to detail and a thorough understanding of the potential hazards. By following the national electrical code requirements, using appropriate equipment, and following safe work practices, you can help ensure that your electrical system is safe, reliable, and compliant.